This is Anna, a young 25-year-old girl who loves her online shopping. On an average, she shops for about 3 to 4 products per week, and this increases during holiday season. Now, let us briefly look into her purchase journey. On a cozy Saturday afternoon, Anna takes her mobile phone and goes to her favorite shopping app. Now she browses through her favorite outfits in the app and finds out that some of her dresses are out of stock or not available in her size. So disappointed with this, she removes all of it from the cart, and then she finalizes and goes to the checkout. When she goes to the checkout, she's asked to fill a myriad of forms, login details, and so on. And then she's asked to choose her shipping options. And then she goes to the payment selector, where she's shown a billion payment options, and then she has to select one among them. She finally finishes her purchase. Now, remember, sorry? Maybe like this? Is that okay? Yeah. So, she finishes her purchase. Remember, Anna is a shopaholic, so she knows about her app really well and about the checkout. And even then, it takes about 3 to 5 minutes to finish a single purchase. And if everything goes well. If anything goes wrong, then easily about 10 minutes. Oh, wait. Not to forget that when she gets her product, she finds out that it's not her size. So she has to return and goes through this entire loop of shopping again. So, on a quick show of hands, who is here like Anna who loves online shopping but absolutely hates the hassles of checkout? Okay, not bad. Maybe not too many online shopping people here. But our research has told that we have about 68% of online shoppers who have abandoned the cart, and about 2.4 baskets abandoned per consumer per month, and with an average order value of 1,200 SEK per abandoned basket. Now let's imagine this. What if Anna is assisted by the app itself? What if she's recommended with her size, her favorite outfits, and she's automatically pre-filled with address, shipping, and shows her favorite payment method, and boom, done. And not to forget that her post-purchase experience is also great, where she's been shown the return options, and she can tag her returns, and everything is taken care of. Wouldn't that be great for Anna? Automating hassles of checkout and enhancing a smooth purchase experience is what I'll be talking today. I'm Deepa Krishnamurthy, data scientist from Klarna Bank AB. So I'm originally from a city called Bangalore, from southern part of India, and I did my bachelor's in telecom and worked 2 years as a programmer, which is when I learned about machine learning for the first time. So in 2014, I came to Sweden to do my master's in machine learning at KTH, and I worked at Carl Zeiss and Ericsson briefly as a machine learning engineer, and then started working at Klarna in 2017 as a data scientist. So in my 2.5 plus years of experience, I've built various machine learning models to understand consumers' payment behavior and for different markets. And to just give a perspective of which part of checkout I'm working on, let's go back to our Anna's purchase flow. So this is payment selector at checkout, and this is what my team is working on. And I'll be walking you through the product that we have built and how we have mitigated the hassles of paying at checkout. This is my amazing team. Can anyone guess the place in Stockholm? Långholmen it is. So yeah, this is a super cross-functional, diverse team. We have 2 backenders, 2 frontenders, 2 data scientists, an analyst, product manager, and engineering manager. So we are sort of a startup by ourselves, so we can build any product that we want to. And we are from Argentina, Dominican Republic, Brazil, India, Sweden, and I'm proud to have added the gender diversity there. So, what is payment selector and why is personalization of payment selector so important to us? To understand this, let's get back our Anna. Now, when Anna comes to checkout to pay, as I said, she sees 1 million options. But what she wants is just to see one payment option that is pre-selected and as a default one, so that she can finish with one-click payment. Now, since Klarna is a payment solution provider, we act as a bridge or a middleman between our consumers and our e-stores. Now, what it means is that we not only care about Anna, but we also care about every single website or e-store she's interacting with. So, from an e-store perspective, what do they really demand from Klarna? To have a smooth integration, A. B, to have frictionless conversion, to show whatever their consumers need, and to have a localized presence in each country they are present in. So our team really has this responsibility of not only understanding consumers like Anna, but also all the websites or e-stores she's interacting with. So to add a bit of complexity to what I'm talking, Klarna has about 130,000 plus merchants integrated, 60 million consumers, 14 plus different markets, and 1 million plus transactions a day, and this is growing. Now, to address a problem of this scale, we need a system which is not only taking care of the large data, but also help us understand each and every consumers in a personalized way. And for this, we leverage the power of machine learning. I wanted to put this because I didn't see anyone do this, thinking that everyone will know, but I like this definition. The textbook way of saying the field of study that gives computer the ability to learn without being explicitly programmed. Now, if you think about this, one of the main differences that we as humans and the computers have is that we learn through our experiences. However, a computer needs to be explicitly programmed so that it can follow instructions. What if computers can learn from experiences too? And that's exactly what machine learning does. And so we feed in data, which is an experience for computers, and it learns from that and tries to predict the future events. Since most of us know here about machine learning, I'll not get into the nitty-gritties of it. Rather, I'll go into machine learning and payments. Firstly, to define a smooth experience while paying in checkout, we need to understand a consumer's favorite way to pay given a context, so that they can finish with one-click payment experience. Now, when I say favorite payment method given a context, what does that really mean? Let's get our Anna back. So Anna is in her commuter train. She still wants to shop, even though she has just 2 stops to her office. She shops, but she wants to pay now immediately. She doesn't want to fill in card details. Anna is now in her vacation, and she wants to use credit card. Now, Anna is in her late-night shopping mood. She's sitting in her couch, super tired, doesn't want to choose too many options, so she picks 2-3 sweaters, which she's unsure of about the size. And she wants to pay later so that she can return. Now, Anna is in her Black Friday season, and she sees all those offers. She gets super excited about it, but her wallet is not excited at all. So she decides to pay by parts. Now, to kind of achieve this sort of personalization, we need to understand Anna in all of these different contexts. So feeding in data to our machines to learn these contexts is a big challenge. And how do we really go about this? The first thing for this is to get data. Now, as a data scientist, personally, this is the most interesting part and also the intriguing part too. And I think most of you will agree to this. So what sort of data will a payment behavior kind of a model will need out there for the audience? Could you guess the features or data that we could use to understand payment behavior? Yeah? Season, yes, that's a good one. Geolocation. Yes, geolocation. Yeah. Great, yeah. So we have purchase-related data. For example, which website is Anna interacting with? How much amount is the cart? And so on. And then you have the consumer-related data, age or gender. And then you have the historical data. For example, what is the last payment option which Anna chose? Or what is the second last option which Anna chose? So in our problem statement, we have more than like 200 features that we have created to analyze such payment behaviors. Now, you may ask, why would you need so much? And geolocation is a very good point to be noted because payment behaviors in each country varies a lot. And I will come to this later during our results section. The same model works pathetically for another country. So you would have to have a generalized model, but catering to different markets. So we have 100 plus features that we create. Once we create the features, we put in our machine learning algorithm to sort of solve what we intend to do. So yes, ranging from decision trees to neural networks, we can use a myriad of algorithms to solve our problems. But as a data scientist, it's our responsibility to know which model or which algorithm to use to solve a particular problem. For our case, to predict a consumer's favorite payment method, it's a typical classification sort of a problem, so we started using classification algorithms. Now, apart from thinking about the problem itself, there are other factors that we need to consider before we even select an algorithm. And that is compliance, data, accuracy, and speed. Now, why compliance in the first step? Because we are a fintech and we know how hard it is to be regulated and to use machine learning models facing the consumers. So compliance, if we want our models to be 100% explainable and interpretable, then we need to probably use a simpler logistic regression or a random forest model, or use a deep net which we can explain, if possible. And then, say, if we want to increase our accuracy or performance, and we have no problem with the data set, we have huge amount of data, then why not go for a deep net? And then comes the production part of it. So if you're going to go live with your model in production, and if it's going to be real-time decisions rather than batch processing, then speed plays a super important role in understanding and selecting an algorithm. So at Klarna, we have models or algorithms ranging from logistic regression till deep nets. And depending on the problem space and these 4 factors, we chose which algorithm to be used. Now, so we have the input data, and then we have our classification algorithm. And then as a output, the model gives the consumer's favorite way to pay, given a certain context. Now, the result of this model is a payment method which will then be shown as the first or the pre-selected default option in the checkout. So our team has built such models for different countries and for different consumer bases. How well has our models performed? Has it really had any impact? Let's see. So the results show that implementing these models, we have increased the precision of understanding of consumers by greater than 75%. Now, when I say precision, what it means is that the consumers have chosen what payment method we have pre-selected for them based on the machine learning model output we have. So imagine that 3/4 of our consumer base actually choose and convert with the payment method that we pre-take for them. And we've also seen that we've increased conversion rate by 0.5 percentage points for our e-store. Isn't this great? Have we nailed the solution? Let's see. What if we are greedy, and what if we want to bring in personalization to one step further higher? For example, if there is a new customer coming into the checkout, we would want to have them feel the sense of transparency and trust. So we would want to show all the payment options that are available in the checkout. However, for returning consumers, the models pretty much know what are their 2 favorite payment options. And they don't care about having all the payment options in checkout. So how about just showing 2 of them? Now, how about an experienced consumer like Anna? She would never want to be shown any other payment method apart from the ones she wants to pay with, so that she can finish with 1 click in her commuter train. So how do we now then get this sort of a personalization on top of the machine learning model that we have built? So we use UX designs on top of these, and we call it the smooth marriage. I'm not sure if all the marriages are smooth, but we call it the smooth marriage. So we try to design different UX components on top of the machine learning model's output, and we experiment this with A/B tests with a small population. And for those of you who are new to A/B tests, A/B testing is basically an experiment of how we can try 2 or more different variants of a particular template on users with the random sampling, and see which one wins based on statistical analysis. So for every UX design that we create and the machine learning model that we build, we run an A/B test to check how our consumers like it with these templates and choose the winner accordingly. Some of the results of these are showing 2 payment options, just the 2 payment options for our returning customers in Sweden alone has bumped up the precision by 7 whole percentage points. And then we tried with the preview mode that we call, or just showing 1 payment option with our experienced consumers, and that has further bumped up the precision by 3.5 percentage points, and this is in Sweden. In Finland, showing 2 payment options has bumped up the precision by 6 percentage points. Now, you may think that, wow, everything is smooth and nice, but then I've just shown you all the positive results. The same thing we tried in markets like Germany. They absolutely hated it. Just collapsing and showing 2 payment options, consumers complain. GDPR, you're not showing us all the payment options. This is bad, you're hiding, and all of that. So it's a different market, and consumers there are more worried about what we do, and especially these days with personalization and machine learning. So we have to be much more creative in the way we design templates and so on. So we are trying different things, and For now, the best thing that has worked is just show all payment options, just increase the precision of the raw machine learning model output for Germany. And that's what is working right now. In Netherlands, show two payment options did work well, but not as good as how it is in the Nordics. So each market is different, and we analyze it in a different way. So, summarizing the entire flow of personalization of payment selector in a nutshell. Firstly, we identified the problem space of enhancing hassle-free payment selector at checkout, defining it in a product perspective, that is identifying favorite payment option given a context, translating it to a machine learning problem. So given certain data, how do we predict consumers' preferred payment method, built models on top of it, added UX, experiment, and then iterate and learn through this entire experience to get the best possible experience for our consumers. Now, bringing back Anna's purchase journey one last time. Personalizing payment selector is just one part of her entire journey. And we already see some great impacts on how it could save time for our consumers and also has improved conversion rates for our e-stores. Now imagine extrapolating this solution to the entire part of checkout and in general, every step of online shopping. I'd like to conclude my talk by saying that by leveraging the power of machine learning, we are not only automating the hassles of checkout, helping Anna and all the Anna out here with an enjoyable purchase experience, but we also save a lot of time, which can be used with our loved ones who matters the most. Thank you.